I'm going to show you a great hack which will reduce your puck prep time and will allow you to produce consistent espresso every time. We're also going to talk about espresso dynamics, which will help you understand the problem with espresso. Simply speaking, in a pump-driven espresso machine, what happens is that the machine pushes hot water at the group head at a certain rate. This hot water then flows through the coffee puck and dissolves all the soluble material in the coffee, and the end product that you get is espresso. But what is it that determines how much of the soluble material in here is extracted? And this is determined by the flow rate in the puck. Now, flow rate is how fast the water is moving through the system, and it is generally measured in grams per second, as 1 ml of water is 1 gram. So when the traditional pump-driven espresso machine first starts, what happens is it pushes water at a particular flow rate into the group head. So typically for a traditional home espresso machine, this might be about 6 to 7 grams per second. And this is called as the machine's water debit, or the maximum flow that the pump can deliver when there is no resistance. But when the water hits the puck, what happens is that it encounters resistance, and so the pressure over here will start to build until it reaches a certain limit. Now, the limit is generally set in most machines by the overpressure valve. Generally, the limit is about 9 bar. And when the pressure reaches the limit, what happens is some of the water which is going into the group head is diverted elsewhere, so that the pressure does not exceed the limit. So what determines the flow rate through the puck? It is the resistance which is provided by this puck. And generally speaking, higher the resistance, lower the flow rate, and lower the resistance, higher the flow rate. And to an extent, the faster that the water flows through the puck, the more soluble material it will carry through, and the more the extraction. Now, another important variable that determines how much of the soluble material is extracted is the surface area of the coffee available for extraction. So if you have really coarse coffee, you have less of the surface area of the coffee exposed to the water. So overall, you might have less extraction. If you grind this same coffee finer, you have more of the surface area available, which means more of it can be extracted. So traditionally, what we've always done is if we wanted to increase the extraction, we made the coffee grinds finer. But there is a problem. What happens when you grind this coffee really fine? By grinding finer, all of this coffee is then packed in really tightly. And we all know that when you grind finer, what you also get is really small particles of coffee, which are called as fines. And all of this increases the resistance of the water to the water flowing through the puck. While grinding finer will increase extraction overall because you have greater surface area, what it also does, it reduces the flow rate through the puck, which will then reduce the extraction. Remember that the water always tries to find the path of least resistance. So if you are grinding really fine and the pressure increases, with high pressures and resistance, what you can get is channeling, which means water finds some weak spots. So you might have water flowing through the channels. So some of the areas are over extracted, while it completely bypasses other parts of the coffee puck, which means some of the areas are under extracted, and what you get is a harsh tasting espresso. What this means is that with traditional espresso, where we rely on grinding finer, it's a fine balancing act between the flow rate in the puck and the grind size, which is why it is very difficult to get consistent extractions. And also with traditional espresso, the puck prep is absolutely crucial. If you have any defects in the puck prep, it will result in channeling, and what you get is a harsh espresso. Now, our understanding of espresso extraction, it changed after this landmark paper was published, which looked at how to systematically improve espresso extraction. And this study found that the extraction was higher at lower pressures for the same grind size and dose. And by lowering the pressure, what happens is that you get a less compacted puck, which means less resistance, and so a higher flow rate through the puck. If you reduce the dose and grind coarser while maintaining the same shock volume, what you can get is a faster extraction, but you also get a more extracted coffee. And this was the birth of the turbo shot. However, this meant that the resulting beverage was less concentrated with less body. A point to note that if you make these grinds really coarse, although the flow rate through here will increase, base area available will reduce, resulting in an overall reduced extraction. Now this concept has been taken to its extreme with soup shots, which is an even faster extraction, but the resulting product has less body, mainly because it is a low pressure extraction, so you get less coffee oils forced through it. So next we come to the problem of variable resistance. The trouble is that as the soluble parts of this coffee are being extracted, the resistance will fall. Now, with a traditional pump machine, as you know, the pump is constantly trying to maintain a constant pressure. And initially, although some of the flow was diverted, as the resistance falls, what it's trying to do is it is going to keep on pushing the water at the maximum flow rate. And this is at the time when the puck is weakest, because most of it has been taken out. Not most of it, but a lot of it has been taken out. So forcing high flow through this fragile puck will cause channeling, which means over-extraction of some parts of the coffee and under-extraction of other parts of the coffee. And the resultant cup is a muddy, imbalanced cup. What you'll see is that initially there might be a peak pressure, but then the pressure starts falling as the puck extracts. Now this problem is exacerbated even more with a light roast coffee that typically does not produce a lot of fines. And so the resistance to the puck, it falls very, very quickly, especially if you're using something like a unimodal grinder that doesn't produce a lot of fines. What this means is that the ultimate espresso that you get lacks body. Essentially, it's a hybrid between espresso and a strong filter coffee. So what is this hack? What is the solution? So what we need to try and do is we need to maintain a constant resistance. So even when the puck is being degraded, we need something to ensure that this resistance does not change, which means that this flow rate through the puck doesn't change, which means that you shouldn't get a significant fall in the pressure. And one way of doing this, one way of maintaining a constant resistance is by using this, a spring over the puck screen. Now this is used in step-down baskets, but it also works for standard baskets. But what you have to do is deliberately underdose, because there won't be enough space if you're not using a step-down. What this means is, as the resistance is constant, flow rate doesn't change, and we get an espresso with great extraction and great body. About 16 grams of coffee here, a bit of WDT, and that's going into this 18 gram VST basket. puck screen on top, and the spring goes on top here. Now, so the paddle is in the fully open position. Start with free infusion. Slowly increase the pedal until the pressure is about 8 bar. I'm aiming for about a brew ratio of 1 to 2.5. I'm going to stop there. So that's 37 grams. So we have extracted 21%. The coffee is incredibly smooth. This has taken away all of the battery acid that you get from really acidic coffee. It is really smooth and rounded, maybe a little bit less clarity than what you would get from a high extraction basket, but nevertheless it is really pleasant.